All right, the next lesson in geometry is called area and perimeter of regular polygons. So let's start with the definition of a regular polygon. A regular polygon is a polygon with all sides equal and all angles equal. Remember, a polygon is any closed shape with no curves. A polygon with all sides equal and all angles equal. Okay, that's a regular polygon. Okay, next thing it says you can circumscribe a circle about any regular polygon. What that means is for any regular polygon, you can draw a circle around it that goes through all the touches every vertex. Okay? You can circumscribe a circle about any regular polygon. The center of the regular polygon is the center of the circumscribed circle. Okay, so that center right there, that's the center of the regular polygon, and it's the center of the circle. The radius is the distance from the center to the vertex. Okay. So this is the radius right here. The apothem, that's new. The apothem is the perpendicular distance from the center to a side. Okay, so this is an example right here. This is an apothem. Okay, see it's labeled right there. Okay, an apothem goes from the center to a side of the polygon and is perpendicular to that side. Okay, that's called the apothem. Okay, the apothem. The figure below is a regular pentagon with radii and an apothem drawn. Okay, so the apothem is this right here. Let me color that in so you can see it better. Let's color it in blue. Okay, this is the apothem in blue because it goes from the center to a side and it's perpendicular to that side. Find the measure of each numbered angle. Well, there's 5 sides in this pentagon. That means there's 5 central angles. Okay, this is a central angle. That's a central angle. That's a central angle. That's a central angle. And this is also a central angle, but the apothem is cutting it in half. Okay, so angle 1 is a central angle. And every central angle is the same in a regular polygon. So I'm going to say that the measure of angle 1 equals 360 divided by 5 because it's 5 central angles. If it was a hexagon, I would divide by 6 because there's 6 sides. Okay? If it was an octagon, I would divide by 8 because there's 8 sides. But this is a pentagon, so I divide by 5 because it's 5 sides, which means that the measure of angle 1 equals 72 degrees. Now, angle 2 is not a central angle. Okay? The central angle is bisected by the apothem. So that means that the measure of angle 2 equals 1/2 of 72, which is 36 degrees. Let's make a note right here. I'm going to say the apothem bisects the central angle. The apothem bisects the central angle. It means it cuts it in half into 2 congruent angles. Now to get the measure of angle 3, we have a triangle, and you should know all the angles in the triangle add up to 180. So I'm going to say that 90 plus 36, because we just found out that angle 2 is 36, plus the measure of angle 3 equals 180. That means the measure of angle 3 equals 54 degrees. Notice how I'm writing my answers. I'm saying measure of angle 1 equals, measure of angle 2 equals, measure of angle 3 equals. Let's do another problem like that. Example 2 is the same thing, but this time we're talking about a regular octagon. 8 sides, but only half of it is shown. So you got to just imagine that there's 4 more sides and 4 more central angles. Okay? So angle 1 is a central angle. So I'm going to say that measure of angle 1 equals 360 divided by 8. The other 4 angles are not shown in the diagram. So 45 degrees. Just for consistency, I'll draw the apothem in blue. This is the apothem. Goes from the center to a side, and it's perpendicular to that side. Now it bisects one of the central angles in half. So the measure of angle 2 is going to be 1/2 of 45 degrees. So 22.5. Same thing to find the measure of angle 3. You have a right triangle, because that's 90, so this angle right here is also 90. So I'm going to say that 90 plus 22.5 plus the measure of angle 3 has to equal 180. $112.5 plus the measure of angle 3 will be 67.5. Now we're going to do the formula for the area of a regular polygon. For any regular polygon, here is the area. Area equals 1/2 times the apothem times the perimeter. If you want to abbreviate that, I'll use capital A for area, 1/2 times the apothem times the perimeter. Okay. Remember, the apothem is a segment. Goes from the center to a side, and it's perpendicular to that side. So let me draw in the apothem just to show you one more time. This is an example of an apothem. And this is the perimeter. The perimeter is the distance around the polygon. Okay. So that's your formula for the area of any regular polygon. Any regular polygon, to find the area, you're going to do 1/2 times the apothem times the perimeter. Example 3, a nice easy one to start. Find the area of a regular decagon with the 12.3-inch apothem and 8-inch sides. So in case you don't know, a decagon has 10 sides. So I'm going to do the perimeter equals 8 times 10. And by the way, if you did not know there was 10 sides, you could just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to get the perimeter, I'm going to do 10 times 8. 10 sides times 8 inches for each side. So the perimeter is going to be 80. So now to get the area equals 1/2 times the apothem times the perimeter. The apothem is 12.3 and the perimeter is 80. Multiply those, you get 492 inches squared. One more easy type, and then we'll get to some hard ones. Find the area of a regular pentagon with 11.6 centimeter sides and an 8 centimeter apothem. Okay, so again, first thing I'm going to say is that a pentagon has 5 sides, in case you don't know that already. So the perimeter is going to equal 5 times 11.6, because that's each side. I'll give you 58 centimeters for the perimeter. Let's label this with inches. Now to get the area equals 1/2 times apothem times perimeter. The apothem, it tells you in the directions, is 8. And we just established that the perimeter is 58. So multiply those together, you get the answer is 232 centimeters squared. Okay. Those weren't too bad, but now we're going to get to the hard ones. All right, so this is a hard one. Example 5. Find the area of the regular hexagon below as a radical in simplest form and as a decimal rounded to the nearest tenth. Okay, so the formula is going to be 1/2 times the apothem times the perimeter. Now the perimeter is easy to get because there's 6 sides and each side is 10 because it's the regular hexagon. So the perimeter equals 6 times 10, which is 60 millimeters. 60 centimeters. That's easy. Now, what is the apothem? Think back to the beginning examples. There's 6 sides, so there's 6 central angles. So I do 360 divided by 6, and each central angle is 60. 60, 60, 60, 60, 60, and the apothem cuts up the other 2 central angles into 30 and 30. Okay. Now, I'm going to take this triangle right here, and I'm going to draw it off to the side. This angle is 90. This angle is 30, which means the missing angle has to be 60 because all the angles add up to 180 in a triangle. This is the apothem right here. So I'll label that as A. What is this side? You have 2 congruent triangles because they both have right angles. The hypotenuses are congruent because they're both radii. And the leg is congruent because it's the same. So if the bottom side is 10, each part's going to be 5 and 5. Now we have to find the apothem. We have a 30, 60, 90 triangle. The formula is long leg equals short leg times the square root of 3. So the apothem equals a short leg 5 times the square root of 3. Now we can go into the area formula. Area equals 1/2 times the apothem times the perimeter. We know the apothem and we know the perimeter now. The apothem is 5 square root of 3. The perimeter is 60. Multiply those together, you get 150 square root of 3. Multiply everything but the radical. So 1/2 times 5 times 60 is 150. And then you have the square root of 3 centimeters squared. And also asked it for a decimal, so multiply those out. You get 259.8. Okay, one more. The hardest one, probably. Find the area of the regular pentagon below as a decimal, rounded to the nearest tenth. So what I'm going to do for this one is I'm going to draw in all the central angles. We don't have anything. We don't have the perimeter. We don't have the apothem. We have nothing right now. Let me draw in all the central angles. This is a hard one. Let me also draw in the apothem. Label each central angle. There's 5 central angles because it's 5 sides. 360 divided by 5 is 72. So each central angle is 72. 72, 72, 72, 72. And then the apothem bisects the last central angle into 36 and 36. Since that's 36 and that's 90, this missing angle is going to be 54. So I'm going to take that and I'm going to draw it to the side. Let me just draw this triangle to the side. I'll do it below because there's a lot of room. I'm going to call this side X. I'm going to call that side Y. If only we could solve that for X and Y. Because Y is the apothem, and we can use X to get the perimeter. And we can't do that because we've done trigonometry before. We cannot use 30, 60, 90, or 45, 45, 90 triangles because those are clearly not the angle measures. But we can use trigonometry, so ka'atoa. So let's start with X. I'll use 36 degrees. I'm going to say sine of 36 equals opposite X over hypotenuse 4. Solve that for X by doing 4 times sine of 36 in your calculator. And give you X is approximately 2.35114. Write out all the decimal points for now. We'll round at the very end. Now let's solve for Y. I'll do cosine of Y equals cosine of 36 equals adjacent Y over hypotenuse 4. So you're going to do 4 times cosine of 36. You get Y is approximately 3.236, 067, 977. Now that is the apothem. Okay, this is the apothem. I'll jot that down. I'm going to use this to get the perimeter. Okay, that 2.35 is half of a side. So to get the perimeter, I'm going to multiply that side by 10 because there's 10 of those. There's 10 halves. I'm going to say perimeter P equals 10 times 2.35, 114, 1009. So the perimeter is going to be 23.5114, 1009. Now let's get the final answer. Area equals 1/2 times the apothem times the perimeter. 1/2 times 3.23. 6067 977 times 23.5114, 1009. 38.0 when you round it. It said round to the nearest tenth. So 38.0 units squared. That problem is very hard because it involves stuff we did earlier this year. That's how you do it. And that's the end of that lesson. That was called area and perimeter of regular polygons.